I think we've all heard the story of Galileo, clapped in irons for science, tortured mercilessly by the Inquisition.
Nobody expects the Spanish Inquisition!
And all for believing something as terrible as the Copernican view that the sun is the center of the universe. As the Indigo Girls once sang, Galileo's head was on the block. It's a deep cut right there. But in the popular imagination, Galileo's story is one of science go boom and religion goes nuh-uh. It's sort of a prelude to everything that comes after. Some believe you can draw a direct line from Galileo's trial to the Scopes monkey trial and the tense relationship between science and religion ever since. But what if I told you that that's not the actual story of Galileo's trial? That even if the church's response was largely negative, and that even if we can criticize the choice to put a man on trial for scientific theory as we think it is, the story is actually more complicated than Galileo, the martyr for science. So what is the story of Galileo's trial? Well, before we begin, let's go ahead and clear the air. What I just mentioned about the relationship between science and faith, and that means all faiths, but the relationship between science on the one hand and belief has a lot going on in that conversation. The reason I'm talking about Galileo is, one, this is my field of history and I like talking about it, but secondly, Galileo and other stories are wrapped up in what's called the conflict thesis in science, which is something that's pretty new. I don't have time to go into it. Just go Google conflict theory science and you'll see all that you need to see. It's this idea that science and belief, science and faith, science and religion are always at odds, that there's a total war going on between the two. Galileo's story always gets wrapped up into that. What I'm more concerned about is to actually understand Galileo's trial in his own day. So let's start by setting the players on the chessboard, so to speak. Let's make sure we understand what was science, what was Galileo doing, and what were his contemporaries aware of, and what were their assumptions when they heard some of these new theories. First things first, you have to understand that in the 1500s, there was nothing comparable to what we call science today. Meaning, if you were to attend a university, let's say it's the best of the best, there is nothing called a science department or anything of that caliber, not even a prototypical early version of a science department during the Renaissance. There really is nothing like empirical hard data being studied. In the Renaissance, as in all of Western history up until that point, science was a field discussed in what you and I call the philosophy department, and more broadly in the theology department. That might strike you as strange. That's okay. But that's because you and I live after the separation of disciplines, where if you attend a university today, obviously these are different departments, different faculties, different interests. That wasn't true back then. So whenever Copernicus or Galileo or any of these folks are discussing astronomy, they are considered, in their day, to be natural philosophers. That was actually the term that was used. They weren't clergy, but they were expected to conform to a certain understanding of how philosophy and, more broadly, theology works. And that's an important foundation. People always scratch their head when they hear that Galileo was charged with heresy when he was arguing for something to do with the solar system, or that his philosophy was under dispute because he was rejecting the old standard models. We're all supposed to groan at the thought that theology is encroaching on science. But that's just how it was done back then. Trust me, if you go back to any discipline in the Renaissance, you're going to have this same thing. Go back and study medicine in the Renaissance. I'll probably do a video on it at some point. It'll make your toes curl, what they thought medicine was supposed to be, and what sources of information they were using. Same thing with politics. You can't go back, for example, into the Renaissance and fault them for not being democratic. It just wasn't an option for them. So in their day, philosophy, natural philosophy, was the domain of astronomy, and therefore to be faulted on philosophical or theological grounds was the norm. Even Galileo assumes this, by the way. There is no one, at any point, for at least 100 years, who is going to start to raise the question of separating these worlds and letting science kind of stand off on its own, under its own empirical weight, you might say. And even then, they're not trying to throw philosophy or theology out the door. That doesn't come until the modern world. Secondly, just speaking as an historian, I do feel it is important to point out that this is not a good century if you're looking for freedom of thought and expression. That's true of everyone everywhere in the 1500s and into the 1600s. Stories like this with Galileo tend to seem so wild in part because it seems odd to modern men and women that someone would be charged with heresy or a capital crime for something that they believed or taught. Galileo, Servetus, Thomas More, there are a long list of candidates that we prop up in this romanticized view that free thinkers were always being bullied by ideologues. Well, ultimately, that's not the case. Again, if I were to describe to you the amount of conformity and the amount of control that early modern power structures placed on average people, it would give you the heebie-jeebies. Just give you one example. In England, there were things called sumptuary laws, which dictated the color and style of fabric that certain classes of people were allowed to wear. Your fit might look good, but if it doesn't fit according to the sumptuary laws, sorry, you got to take a step down. Now, people would riot if that were the case today. We are so accustomed to free thought, free expression, that obviously anything that feels like control always makes us a little bit irked. Well, that goes up by a factor of about 1,000 when you're talking about big ideas and big leaps forward in matters of science. But don't mistake this as simply one side, the church and theology and philosophy are ideologues, and Galileo is just simply a free thinker demanding freedom of expression. He's not, actually. Besides, I'm not entirely convinced that the 20th and now the 21st centuries have fully gotten away from the idea of bloodshed for the sake of ideology. Let's pump the brakes a little bit. But that's the place we have to start. Galileo is seen as a natural philosopher. Therefore, everything he says and teaches is going to be judged according to those principles. So now when we turn to the question of the geocentric and the heliocentric views, we can see a little bit better where Galileo fits into this picture. All right, let's start on the same page. Geocentric, of course, is the idea that the Earth is the center of the solar system. More on that in a second. But it's the idea that the Earth stands in the center, really of the universe itself, and that all the celestial bodies move around us. Heliocentric, of course, has since been proved by science, and it's the idea that the sun is the center of our solar system. But what did people actually believe about astronomy and the universe when people like Copernicus and Galileo are coming onto the scene? Well, if you were to go back to the 1500s and be educated in a university in, say, Italy, the best of the best, you would have been taught not just the geocentric view of the world. Of course, everyone believed that the Earth was the center of the universe. This had been taught by Greek philosophers, Roman philosophers, and Christian theologians for about 2,000 years. Yes, it actually predates the time of Christ. And then you add to that the fact that a few places in the Bible seem to confirm this when it says that the sun stood still in the sky for a while, or this language of the sun rising and setting. All of this seemed to confirm the basics. The Earth is the center of the universe. Geocentric views, in other words, were just basic knowledge. Everyone taught it. Doesn't matter if you were a Christian or a Greek philosopher. It was as common for them as it is for us to talk about the periodic table. It's just hard fact. Beyond the geocentric view, though, and not a lot of people talk about this, there was also a more crucial assumption about the solar system or about the universe, and that is that it moved in perfect circular motion. So not only is the Earth the center, but everything around us is said to be moving in a perfect circle. This is the basics of what philosophers like Aristotle and Ptolemy had taught, and it was assumed to be the norm. Perfect circles in heavenly motions around us. So that's the basics. That's the assumption. Well, what tools did they have to perhaps come up with an alternative theory? On that, it's actually quite startling. Well, again, going back to the university, the only discipline that was studied that we would consider to be a hard science was math. There were no courses on astronomy. They did not have a curriculum based on experimentation or these types of things. Medicine would probably fall into the category of hard science, but again, medicine is not what we think of medicine fully in this time and age. So really all they had was math. But let's slow down again when we talk about math. Math in the Renaissance wasn't seen as all that important. My kids would probably agree at this point in their journey. It was useful. Math was useful. It was practical. You used it to create calendars or calculate the date of Easter. But it couldn't, and this is important, it couldn't tell you anything true about the world around you. Now, I have friends who majored in math, who are very good at math. They love math for the way that it seems to reveal the inner order and the inner structure of the world around them. That's not how the Renaissance viewed it. They would say that the only thing that can tell you something true about the world is, again, natural philosophy. Math was essentially a hobby. Also, if math is the only real hard discipline they're studying, you have to realize that the math that is being studied pales in comparison to what you and I know to be math today. Essentially, all they had was geometry, and you usually get to that in freshman or sophomore year in high school. And even the study of geometry in their day was not as developed as it will become in future years. Just to give you an example, Copernicus and Galileo are living roughly 100 to 150 years before Newton and Leibniz begin to develop and debate about the concepts of what we today call calculus. So I used to always tell students, if you were pretty good at math and you studied it fairly deeply through high school and perhaps into college, you would have had more mathematical foundation than Galileo or Copernicus ever had. Again, math was a hobby. Galileo himself was a lecturer in math. He made roughly 1/3 or 1/4 the salary as the other faculty and the other big wigs. Okay, so knowing all this, let's do a thought experiment. I want you to go outside on a clear night and try to imagine that you've been taught that for roughly 2,000 years, the Earth is the center of the solar system or of the universe, and that everything around us is moving in perfect circular motion. You have geometry, and that's it. Don't use computers, don't use calculators, nothing. All you have is your naked eye and geometry. Look up at the night sky, and without any modern tools or assumptions, try to figure out what's wrong with the geocentric view. Ask yourself these questions. How big do you think those stars are? Just with your eyes. How far away do you think they are? What orbit do you think that they're taking around us? How big is the sun and the moon? I'll wait. Couldn't do it? That's because it's incredibly hard. You have your eyes and you have geometry. How did they work this out? And that is actually a more interesting story. Let's start with Copernicus, since he is rightly considered to be the groundbreaking thinker who started scientific thinking moving towards heliocentric views. I'm not going to say too much about him and his life. Maybe I'll do another video on that some other time. But the basics are that Copernicus, around 1514, had already come up with some of the ideas of the heliocentric views. He had written a book on the subject that he did not publish, but that he showed to some of his friends. And there was some curiosity about this. Then, after more reflection, more study, in 1543, Copernicus published his very famous On the Revolutions of the Heavenly Spheres. The world would never be the same, or so we are told. To this day, I have yet to find any sort of Wikipedia-level article that doesn't make it sound like this book was earth-shattering. The reality, though, is the book was almost entirely ignored in its day. It wasn't even a flash in the pan. There was no pan. Nothing. Almost everyone thought that this was some kooky idea from a rather obscure philosopher. As we'll see in a minute, it takes Galileo for the Copernican view to really start taking shape. So what is this book, this On the Revolutions of the Heavenly Bodies? Well, it's not a science book at all, at least not in the modern sense. It's actually, as I already said, almost entirely philosophy with a little bit of geometry thrown in. That's about it. It is not a mic drop. It is not a conclusive empirical paper that proves that the sun is the center of our solar system. It was, at the time, an interesting problem for philosophy, since it called into question some of the roots of the Ptolemaic view about how the celestial bodies moved. And the key is in the name. Notice that nothing in the title of that book says anything about the sun. What's his focus? The revolution, or the orbit, we might say today, of the heavenly spheres. You see, what Copernicus and others noticed, looking up at the night sky like I asked you to do earlier, is that the stars and the visible planets do not move in a way that suggests perfect circles. Sometimes they seem to move backward to the naked eye if you chart them. So Copernicus is essentially saying, philosophically, with a little bit of geometry, we can't make sense of this if the Earth is the center of the universe. That's it. He published it, and most people did not read it or care. Now, I am in no way denigrating what Copernicus wrote. If anything, I am elevating it. He essentially brought a knife to a gunfight, and he still won. He did not have the tools that you and I have. He just had simply some observations that called into question some of these ideas of how the spheres move. But suffice to say, if you and I were living at the time, and you and I were part of the intellectual elite, we would think that Copernicus was at best an interesting thinker. At worst, he was a bozo. And that is largely the reaction to Copernicus in the mid-1500s. Protestants, by the way, almost universally thought that Copernicus was crazy. Luther and Calvin are both on record as saying that heliocentrism is just the latest ravings of those crazy Catholics. In the Catholic Church, however, there was at most a hint of an interest with some, but almost no one changed their views on the matter, and they carried on believing that the Earth was the center of our universe. So if we freeze time in scientific advancement at, say, 1550, when Copernicus is writing and publishing his work, it is probably the case that heliocentrism would not have been adopted. You see, this wasn't like normal scientific advancement where Copernicus had proved the issue beyond a reasonable doubt, and it just took time for folks to confirm it. If you look at the history of Einstein and relativity, there is a bit of that lag that happens, where he's kind of mic dropped the moment and proved it, but it takes a few years for folks to all fully get on board and to find the confirmation of what he said. This isn't that. The problem with Copernicus is there just wasn't enough empirical evidence to prove the case. Without that evidence, the old dogged belief that the Earth was the center of the universe was going to continue. Theologians and philosophers, in other words, were not the only men who refused to accept the heliocentric view. Even Galileo himself, and this is important, even Galileo himself thought Copernicus was wrong, and he spent most of his life rejecting the heliocentric view. So what happened? First, and this is always crucial in scientific advancement, there is a rapid increase in technology. In the later 1500s and early 1600s, Galileo heard of this new invention of what we today call the telescope. Now, it's often believed that Galileo invented it. He did not. It was patented and developed in the Netherlands, just not perfected. Galileo perfects it. There's a whole science behind the precise grinding of lenses and glass. It's not always that easy. But the development of the telescope is the real jump here. He puts these two lenses together, he comes up and solves the refraction problem, and then he puts his eye up to the glass. And doing so allowed him to observe the night sky up close for the first time. Suddenly, Galileo could observe what before had been impossible: the moons of Jupiter, mountains and valleys on the moon itself. He noticed the phases of Venus as it orbited, and he noticed sunspots for the very first time. The night sky was suddenly brought close. That is the real turning point. To give you a modern example, physicists in the 20th century theorized for quite some time about subatomic particles. These ideas made a certain amount of sense, you might say, on the chalkboard. The presence of things like quarks and hadrons, to name only two, were theoretical. Scientists for a little while were able to at least be a little skeptical if these things even existed. But then, in 2008, the Large Hadron Collider went online. And I believe at the time just about every physicist and amateur scientist in the world was eagerly watching to see what was discovered. And subatomic particles have been discovered. In the past 15 years, extraordinary amounts of empirical evidence have now proved beyond a shadow of a doubt the presence of many of these particles that were once theorized. It is almost the exact same parallel in Galileo's day. Copernicus had some ideas, he had some theories, but it was only with the leap in technology and empirical evidence that Galileo started to revise his earlier rejection of Copernicus. Suddenly, it wasn't just philosophy anymore. It was increasingly clear through the lens of a telescope. For the rest of Europe, though, they did not have a telescope, and that's an important fact. For them, it was still just philosophy. But, and this is the important thing as we turn to the trial, the times had changed. Copernicus in the 1550s could espouse some ideas that were a little out there, you might say, at least according to their day. By the time that Galileo looks through that telescope, though, Europe is in a different state of mind. These weren't just philosophical ideas anymore. This was the time of the wars of religion. And now everything, every idea, was a battleground between the forces of Protestantism and Catholicism. And because of that, Galileo will go on trial. Okay, the trial itself. Let's go ahead and get rid of a few myths so that I can talk about it with some clarity. Galileo was not thrown into a dungeon, he was not tortured, and he was not, you might say, physically forced to recant. He was not sent to some gulag or some kind of labor camp because of his scientific views. It's not a pretty picture, I'm not going to whitewash it. But it's not what the popular imagination would have you believe. As we have seen, Galileo was born after Copernicus published his book, and for much of his life he rejected the heliocentric ideas. He just didn't buy it. Of course, what drove Galileo is this idea of experimentation. He liked to challenge, or at least double-check, you might say, verify, held assumptions in the realm of natural philosophy. So at one time, famously, Aristotle had argued long ago that two objects of different size, different mass, if dropped from a certain height, will fall at different rates. That made sense to him in his day. Aristotle said the heavier thing will fall faster. If you drop a bowling ball and a pebble, the bowling ball will hit the ground first. Galileo famously went up to the top of the Tower of Pisa with two different objects of two different masses and dropped them, and they landed on the ground at the same time, ultimately disproving Aristotle. Now, it just goes to show, people didn't lose their mind about that. You were able to disprove things in natural philosophy as long as you could demonstrate it. And in this case, Galileo demonstrated it. By 1609, Galileo had now perfected the telescope, and he began to, what he thought, demonstrate again conclusive proof about some of these new findings in our night sky. He published his findings in two really important books, The Sidereal Messenger, published in 1610, and The Sunspot Letters in 1613. I love those titles, by the way. They feel like fantasy books. In those books, he not only described what he witnessed, what he saw, but he drew diagrams and pictures of them. In Galileo's mind, he was doing much the same thing that he had done with, say, the experiment on the mass of two different objects. He saw some findings, he thought he would point it out. Only now theologians and philosophers, those traditionalists who had not believed Copernicus before, were, let's just say, a lot more concerned with heresy and conformity in the 1600s than they were in the 1550s. By this point, the Catholic Church had lost vast areas of Europe to Protestantism. And that really does need to be pointed out. Everyone thinks that the Catholic Church is crazy for being so scared about losing everything. But they went from essentially the only church in Western Europe to now having lost Scotland, England, the Netherlands, large parts of Germany, at least half, many of the Swiss cantons, and large parts of Eastern Europe. And now France was in a dogfight to see if it would remain Catholic or if the Huguenots would eventually win the day. Don't have to condone it, but you can understand it. The Catholic Church was very concerned about people rocking the boat. So Galileo looks through the telescope and he discovers plenty of evidence to back the Copernican view. What's interesting is Galileo knew that this would run up against certain traditional views on the Bible. Not that the Bible had been used to argue the geocentric view, but rather that because the geocentric view had been inherited from Greek philosophers, certain passages of the Bible had become traditionally ascribed to that same view. It's the other way around, in other words. And that was a thorny matter, because to go against certain traditional interpretations, you had to be very careful, especially if you're not a churchman or a theologian. Galileo kept most of his views on the Bible private, but in letters he did argue that the Bible did not conclusively hold to any particular view of physics and celestial motion. That, by the way, I don't think anyone would have any problem with today. But in his day, he was just simply sort of nudging that point forward. The Bible isn't a physics book, obviously. But in 1615, a very conservative Dominican lodged a complaint in Rome against Galileo. His books, he argued, had gone against the traditional views of Scripture and the earth. The result? Nothing. Nada. Galileo, it was determined, had not published anything explicit about Copernicus, nor had he denied the authority of the Bible. So the charge of heresy was baseless. Galileo, in fact, was not even summoned to Rome, in large part because his reputation was so well received that they knew for a fact that he was not a heretic and that the charges were flimsy. For reasons not entirely known, however, Galileo went to Rome to defend himself anyway. Maybe it's something about his personality. He felt the need to go and make it crystal clear that he is no heretic. You see, the Inquisition had gone after Copernicus and his views of heliocentric ideas, largely, though, not because they were anti-science, but because Copernicus, in his book, had been so renegade, you might say, against traditional philosophy. Go back to what I said earlier. It's a philosophy book. And after Luther and Calvin and Cranmer and all these Protestant theologians with their renegade ideas had led churches out of the Catholic Church, they just weren't in the mood for any more renegades. Copernicus was very easily tarred and feathered as one. But at this point, Galileo is not the target. The Inquisition at this time was spearheaded by Robert Bellarmine, a man that would become essentially synonymous with the Catholic Jesuit attempts to hold the line against heresy. Now, it's important here. Bellarmine and Galileo met, and Bellarmine did not condemn or take an aggressive stance towards Galileo. He just told him to back off the topic because of the negative views about Copernicus in Rome. Galileo, by the way, agreed. He said he wasn't going to be kicking the hornet's nest. Several months after this meeting, the Index of Prohibited Books announced in general that philosophical discussions about the earth being anything other than the center of the universe would be considered a heretical stance, since it went against the Bible. Yes, it's at that point that people start to get a little bit icky feeling. But Galileo left this time content. He'd argued his point, he'd proved that he was safe, and he left to go back to do his work. He didn't want to stir up controversy. He doesn't do anything for 8 years. He just continues to teach and stargaze. Then, in 1623, Pope Urban VIII comes to power. He's elected. And Galileo seems to have been inspired by this, thinking that it might be okay to start talking about these ideas in public again. You see, Urban had actually been a vocal supporter of Galileo's earlier books. And at the time, the Pope said that he found some of his arguments conclusive, and that some of the ideas of Copernicus and Galileo could easily be harmonized with the Bible. And then, this is important, without seeking direct approval, Galileo thought it feasible to release a book called The Dialogue in 1632 and discuss the issues in print. Okay, what is this dialogue? The dialogue is really the crucial misstep, if you want to call it that, for Galileo, at least on a personal level. The book is really simple. It's a Socratic dialogue debate between three positions. One character is Silviati, who holds to the Copernican view. Sagredo is an educated layperson. He's the second dialogue partner, and he is neutral on the matter, and he is listening. And then there is Simplicio, the one who holds the traditional views. Now, there's a few issues here. For one, Galileo vaguely refers to the traditional views as simple or simple-minded. That's what simplicio means. And it seems to be a bit of a dig, in print, at those who would put their head in the sand and refuse to look at any of the evidence. Now, Galileo has in mind a couple of people here. One, very famously, is a colleague at a university who, when Galileo brought the telescope, he asked him to look through it, and the guy refused because he didn't want to see the evidence. He just wanted to hold to the traditional views. And you thought modern academia lacked credibility from time to time. So when Galileo is poking fun at the simplicio, at the simple-minded views of the traditionalists, he makes one infraction here, which is that he's not clear who his target is. A Socratic dialogue does tend to stir up controversy. Just ask Socrates how that worked out for him. And the problem here is that Urban, the new pope, felt very slighted by this book, suspecting that Galileo had meant simplicio to be a reference to him. You see, people were going to complain about Galileo and Copernicus no matter what. Only now, with the publication of the dialogue, a lot of the goodwill, if not most of the goodwill in Rome, was now gone. He had lost an ally in the Pope. So, 1633, Galileo is summoned to trial, again. By this point, he is old and in poor health, and he's largely confused why people keep coming after him. The trial, though, turns on one legal issue. Bellarmine had prohibited Galileo from holding to any particular view. That's the important line. You cannot hold to any view that rejects the traditional reading of Scripture. He did not bar Galileo from discussing the matter openly in any kind of Socratic dialogue form. Galileo argued that he had held to the letter of the law. His defense was that he had publicly advocated nothing, only laid out the arguments for both sides, with a third party as the dialogue partner. The Inquisition, though, was not buying it. And as lawyers do, the case resulted in plea bargaining. Galileo would not be charged with disobeying the Inquisition or of holding heresy if he pled guilty to the lesser infraction against defending anything to do with Copernicus. Galileo actually agreed, admitting in the trial that the book could be confusing since it was written in a way that seems to make traditional views seem stupid. At this point, the Inquisition, though, reacted a bit more severely. They argue in the minutes that they do not trust or believe Galileo when he says that he does not hold to any particular view. So they imputed to him the, let's just call it medium-level charge of, quote, vehement suspicion of heresy. The documents conclude that, quote, we condemn you to formal imprisonment in this holy office at our pleasure. And that's about all the evidence we have. I'm not going to go too much into it. There is a book that deals with this. It is a very important book, published by Harvard, a lot of scholars. This is not some kind of pull the wool over your eyes kind of research. And this book discusses Galileo and lots of other myths in the history of science. I'll include a link in the description below. But needless to say, for about 200 years, there was this belief that Galileo had been tortured and perhaps imprisoned to force him to recant. But we now know the truth. He was not hung from the ceiling by his wrists, and he was not humiliated or beaten until he submitted. He wasn't even imprisoned. He housed in a nice villa in Rome during the trial. But he was condemned to house arrest. They essentially silenced the old man. And he was old. Eventually, he was allowed to return to Tuscany, but he had to remain on his estate for the remainder of his life. And for now, the Church had made its rulings on the views of Copernicus. Well, the story of Galileo is complex. And as I've said, it's not a pretty picture. In 1992, Pope John Paul II officially apologized for the Galileo affair and admitted that the Catholic Church had erred to treat him in this manner. Ladies, if you think that your man takes forever to apologize, at least it doesn't take 350 years. But hopefully now you understand some of the forces at work and some of the reasons why Galileo was put on trial.